During this exercise, we are going to practice the technique of fixation of a trochanteric fracture with a dynamic hip screw. Here one can see the principal parts of the DHS implant, the DHS lag screw shown here, and a DHS side plate. The basic technique is briefly outlined as follows. The fracture is reduced and provisionally fixed with Kirschner wires. A guide pin is then introduced in the femoral head and its length measured. Then the tunnel for the implant is drilled and the lag screw introduced. Finally, the barrel of the side plate is introduced over the screw shaft and fixed to the femur with screws. Now, using the model, we will demonstrate the proper use step by step. First, we reduce the fracture. Since soft tissues are absent in our exercise, we begin by fixing the fracture with a pointed reduction forceps. We now provisionally fix the fracture with Kirschner wires. These must be placed superiorly in the head so as not to interfere with later guide wire placement. We would now estimate the neck shaft angle. For this exercise, we choose an angle of 135 degrees and so select the appropriate guide. We next place a guide wire anterior to the neck and hammer this into the head using the appropriate angled guide to provide a measure of anteversion of the femoral neck. The angled guide is now placed on the femoral shaft and a hole drilled in the cortex with the 2 mm drill bit. The direction of the drilling should be through the center of the femoral head and is parallel to the previously placed Kirschner wire. The guide pin with the threaded tip is now used. The pin is placed in the small Jacob's chuck. Using the small air drill and 135-degree guide, the pin is placed through the head and neck, parallel to the previously placed anterior pin. The drill and angled guide are now removed, as well as the previously placed Kirschner wire. The DHS direct measuring device is now selected and placed over the end of the guide pin. The measuring device shows the length of the portion of the guide pin which has been drilled into the bone. Here it shows 120 millimeters. That means that the distance from the lateral cortex to the joint surface, in this case, amounts to 120 millimeters. This is demonstrated here. The hole should be drilled to end 10 millimeters from the joint and thus should be only 110 millimeters deep. Here is the triple reamer. The front part drills the hole for the lag screw. The middle portion drills a larger diameter hole for the barrel of the plate. And the back part countersinks the cortex for the connection between the plate and barrel. Behind the drill connection is a millimeter scale. The sliding nut is loosened and the desired drill depth of 110 millimeters is set and the nut is tightened. The setting of 110 millimeters can be checked in the tightened position if desired. We next introduce the triple reamer into the universal drill and place the drill over the guide pin until it contacts the bone. The hole is then drilled to the point of the third stage of the drill bit. The drill should be run at full speed throughout. With the plastic bone, the drilling debris must be shaken out. With hard cancellous bone, as well as with the exercise bone, the thread must be tapped. For this purpose, the short centering sleeve for the tap and T-handle are selected. The centering sleeve for the tap is placed over the tap and the T-handle is connected. The tap is now placed over the guide pin and the centering sleeve is pushed firmly into the drill hole. The hole is then tapped to 110 millimeters. The depth of the hole is shown by the markings on the tap. From the screw selection, a DHS lag screw of length equal to the depth of the drill hole is selected, in this case 110 millimeters. The coupling screw is placed into the guide shaft and screwed into the inner thread of the DHS lag screw. The flange slot of the guide shaft and screw must be properly aligned as shown. The longer centering sleeve is now selected. It is slid over the DHS screw guide shaft assembly and assembled with the wrench. This is then placed over the guide wire and screwed into place. As soon as the zero mark of the screw wrench assembly reaches the lateral cortex, the DHS screw is at the end of the drill hole, as shown here. This means that the point of the DHS screw is 10 millimeters from the joint. In osteoporotic bone, the screw can be carefully inserted up to 5 millimeters deeper. At the end of the procedure, the handle of the screw wrench must be aligned parallel to the long axis of the femoral shaft so that the side plate will slide over the screw. The turning is clockwise only. In observing a screw in this position, it can be recognized that the shaft sides are flat. The hole in the barrel of the plate is similarly flat so that the screw locks when the plate is applied. We remove the centering sleeve and the DHS wrench. From the DHS plate selection, a 4-hole 135-degree plate is chosen and placed over the guide pin and DHS screw and temporarily held in place with a self-centering bone-holding forceps. Subsequently, the coupling screw is loosened and the guide shaft assembly is removed. Using the small drill, the guide pin is removed by turning in a counterclockwise direction. The 2 provisional Kirschner wires are likewise removed. The plate is impacted with the hammer and impactor, and concomitantly, the fracture zone is similarly impacted. The DHS plate is then attached to the shaft of the femur with 4 screws drilled in the neutral position. The fracture can be compressed with the DHS compression screw intraoperatively if desired. This, however, is seldom necessary. With osteoporotic bone, the compression screw must be carefully used in order to avoid tearing out the DHS lag screw. After achieving compression, the compression screw should be removed. The lesser trochanter is subsequently fixed with the malleolar screw. At the time of hardware removal, the plate and screws are first removed, followed by the DHS lag screw. The long coupling screw for DHS removal and DHS wrench are now selected. The wrench is placed over the DHS screw, and then the coupling screw is attached. The DHS lag screw can then be removed without difficulty. Should the guide pin become loose, it must be exactly repositioned, or the screw may not come to lie in the correct position in the femoral head. In order to obtain optimal centering of the pin, the centering sleeve is first placed in the drill hole. Following that, a screw is placed within the centering sleeve. The guide pin can then be re-drilled in this way into the exact center of the previously made tract.